Hello class, this is section 3.5, and in this video we are going to discuss the variation of parameters technique. So this technique you use when we have a solution already for the homogeneous equation. So we already know that y1x and y2x are the two linearly independent solutions for the homogeneous equation y prime equals px, y prime equals 0, and we want to find a particular solution, and this is the equation that has an fx in it. The key to this variation of parameters technique is that we guess that the solution yp has the form u1x y1x plus u2x y2x. There isn't really any reason to see why this is true. It's just a guess, and a guess that turns out to work out. These are the y1x and y2x that come from the formula for the general solution of the homogeneous equation. So these are the y1x and y2x that solve the first equation. And this guess comes from, like, if a y with constant parameters solves the first equation, maybe if we let it vary a little bit, let it change a little bit. So these are not constants, these are functions of x. Maybe we can solve the second equation. So the goal is to find u1x and u2x. So let's first take the derivative of this function, this y prime. So we use the product rule to get that this is equal to y1 prime y1 plus u1 y1 prime for the first part, and u2 prime y2 plus u2 y2 prime. So this we can collect the terms again in this form. I'm just rearranging terms here. So let's do something that is a bit of a algebraic trick. So we have to find two functions, u1 and u2, and we know that to determine two functions, you determine them using two equations. So we only have one equation really. So this is the equation that we have, the yp equals u1x y1 u2 y2. So it's actually acceptable to make up a second equation that makes your job easier. So the thing is, like, we still have two equations and two unknowns, so we should still get an answer. And our second equation is going to be one that makes our job here a little bit easier. So we write down, we assume u1 prime y1 plus u2 prime y2 equals 0. So this is our second equation. So now we have two equations, this one and this one, and two unknowns. So it makes sense that we should get a single answer for u1 and u2. But what this choice of the second equation does is that it makes our job a little bit easier. So now we just have up prime equals u1 y1 prime plus u2 y2 prime. And what we can do here is to take the derivative and use the product rule again. And this time we're going to get this. So now we use the fact that y1 and y2, if you recall, are solutions of the homogeneous equation, of the first equation here. And what this means is that y1 double prime is equal to minus p y1 prime minus q y1. I'm just rewriting the the first equation here. And the same thing for y2 double prime. So remember that y1 and y2 are both solutions of this equation, so that's why we can do this. We can now plug this in the equation for yp double prime here and here. What we get is yp double prime equals, let's first write down the term that we don't play with, and this just comes from this term plus u1 times minus py1 prime minus qy1 plus u2 minus py2 prime minus qy2. So this comes from, let's see if I can draw the arrows right. This comes from here, and this comes from here. So we can recollect the terms as follows. So yp double prime is now just u1 prime y1 prime plus u2 prime y2 prime plus p minus u1 y1 prime minus u2 y2 prime plus q minus u1 y1 minus u2 y2. But this actually simplifies the equation, because now we just have u1 prime y1 prime plus u2 prime y2 prime. So this first term that's next to the p, we know that u1 y1 prime and u2 y2 prime, that this comes from our assumption, comes from here. Yp prime is u1 y1 prime, u2 y2 prime, and using that we can just write down this is equal to minus yp prime from this equation, the equation in blue. And we also have that q, the q term, is going to be multiplied by our expression for yp. This one in pink over here, yp equals u1 y1 u2 y2 that we originally came up with, and that's just going to be minus yp. So this is our expression for yp, and substituting into the equation that we were going to solve in the first place, the big equation, if we substitute this y double prime in, what we get is that the p's and the q's all cancel out, and we're left with u1 prime y1 prime plus u2 prime y2 prime equals fx. It's just this term over here, the first term over here. It's just what remains. And this is going to be one equation. And remember that we had a second equation over here. And that's just going to be our two equations that we use to solve for u1 and u2. I'm actually going to assign this as a homework problem to solve for u1 and u2, but it's fairly straightforward. You just have two equations and two unknowns. But we'll probably do this in class. And at the end of it, we get a formula for yp. And the solution will look something like this.